Hi, everyone. So in this example, we are looking at an SR flip-flop, and we don't know the internals of the SR flip-flop, but it doesn't matter because we're not going to enter the illegal state, so we're not worried about the outputs in that state. To refresh, we know that the SR flip-flop has 4 possible states it could be in. So it's got S and R being 0, 0. I'll write it differently here. I'll go 1, 0, 0, 1, and 1, 1. We know these are the no change state, the set state, the reset state, and the invalid state. And for no change, Q and Q bar stay the same. So I've got Q staying Q and Q bar staying Q bar. For the set state, Q becomes 1 and Q bar 0. For the reset state, Q becomes 0 and Q bar becomes 1. For the invalid state, we don't know because we don't know what the internal implementation of is there, but we're not using this in this example. Okay. Now I've drawn the SR timing on the screen, and this is the one that the example that we did in our live class, but I've just hand drawn it here. The first thing you would do when looking at this example, so we've got S and R, it's a timing diagram, so we can see that their value is changing with time as we go left to right. And what we want to do vertically is we want to align or just sort of segment the timing diagram into where S and R, either one of them, change state. So the first change of state is here. The next one is here, and then here, and then here. Ignore the fact that my graphs aren't exactly looking square because they should be. That's just bad drawing on my part. So I'm dotting down the transitions. And what I want to do, I want to look at each of these states and see what the values of S and R are. So we know here S is, sorry, that's a 1. Here S is high, so that is a 1. Here for these, S is low. S goes high, S is low, S is high, S is low. For R, R is low, then high, that's a 1, low, high, low. Okay, so just sort of saying for each of these states. Now for the first state, and actually I should say what we want to do here, we want to draw the output. And because we know Q and Q bar are going to be opposite to each other, I can get away with just drawing Q for this example. So with S1 and R0, that's going to be the set state here where Q is high. And then when it becomes 0, 0, that's this state here, which is the no change. Now remember, for no change, it depends on what the value of Q was before we entered the no change state. So because Q is high, it's going to stay high. Then S goes to 0 and R goes high. So that's going to be a, well, S was already 0, but that's going to be a reset state. So Q is going to go low. Then we're up against a hold state with S and R both being 0. Since we're already low, we're going to stay low. Then we get set high, and then we get held high. Then we get reset to low, held low, reset to high, held high. So if I was going to come along and label these states, this would be set, no change, or hold, reset, no change, set, no change, reset, no change, set, and no change. So you can see the value that we're in the no change state can be different, and it actually depends on what we were just before that state was entered. So it's holding Q at whatever that output was. Okay.